All right, so I'm going to do two more examples here about this factoring trinomials. So if we look at this one is very similar to the one that we did before, except it has way better numbers. So we have 9, 12, and 4. Now 9, 12, and 4, again, they don't have something that you can factor something out. And we want to look to see if we can factor anything out, even if it doesn't get rid of the 9, and we don't. So again, we're going to do that thing where we do 9 times 4. Okay, apparently I can't write it with it sideways. Okay, and that equals, or that way, 36. So when we do our super diamond, we're going to put 36 on top, and it's positive, and then we put positive 12 here. So we want something that multiplies to 36 and adds to 12. So again, I'm going to list the factors, and this time I am just going to do all of them. If we had another one where it was super big, I wouldn't, but because it's smaller, we can do it this. Okay, so we got 1 and 36. We have 2 and 18. We have 3 and 12. We have 4 and 9. And then 5 doesn't work, but 6 does. 6 times 6. And we're looking for ones that add to 12. And so if we add, we get 37, we get 20, we get 15, we get 9. My goodness gracious, is 13, and then we have 12. Okay, so that means that our two numbers that we're going to put in our x are 6 and 6. So we're going to put 6 here, and we're going to put 6 there. Okay, so that means that we have 9x. So remember, we're keeping the 9, but we're going to eventually factor out anything that we need to factor out, plus 6, and then the exact same thing, 9x plus 6. So they're all the same. So 9 and 6 can both be divided by 3, so we're going to divide out a 3. And since it's the same thing, I'm just going to go ahead and do it like that. So we have 3x plus 2, and then we have 3x plus 2. Okay, another way to write this is 3x plus 2 squared. So that's another way to write it. Either way works, but that's another way to write it. All right, so then we're going to come over to this side, and I don't know if I've got a zoom button, but I might be able to resize this so it's a little bigger. Yes, okay. So what is the factorization of this polynomial? So this time, when we're talking about this, again, we have to look at the numbers in front. And I know that 3 and 33 share the same factor, so I need to see if 54 can. Now the trick with 3's is we're going to do 5 plus 4. We add the digits up. And what do we get? We get 9. Because 9 can be divided by 3, okay, 3 times 3 is 9, then that means that 54 can. So that means that our GCF, and we haven't, the other two didn't have a GCF, but our GCF for this one is 3, which is super nice because that means it is just the number out in front. So we're not going to have to do super diamond, we just will do a regular diamond, and that's going to make it so much easier. So we are going to factor out a 3. Now we're not reducing. Here was reducing, so this is reducing. Let's say reduce. Okay, and this time is factor. The difference with this is when we factor, we still have to keep this 3. So we're going to write a 3 outside of a set of parentheses, and then we're just going to divide out. So dividing the 3 here, we get x squared. Divide the 3 here, we get plus 11x, and then here, which I'm not actually quite sure what that is off the top of my head, probably something with an 8 though, so that would be 1. Yep. And so that would be 18. So plus 18. Okay, so now that we have this, what we're going to do is we're going to do the normal diamond method, which is awesome. And again, there's multiple different ways that we can do factoring. I like to use the diamond method because it's the way I was taught, and it makes the most sense to me. All the methods are using the same questions. So what numbers multiplied to the last number that add to the middle number? So again, we're going to do our factors. I'll do, actually, let's see, let me erase. Okay, but I don't have a Surface Pen, so I can't do that. I'm using a tablet, so it's not the same thing. This is like my second day using it, so I'm a little rusty. All right, so 18, and we're going to figure out the factors. So we have 1 and 18, 2 and 9, ding, 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 3 and 6, 4, 5, and then back to 6. Okay, so I said ding, ding, ding because we need to add it to 11. It could be subtracting, but because they're both positive, if they're both positive, it's going to be adding. So if we add this together, we get 11. So we're going to put 2 here and 9 here. Because 2 times 9 is 18, and 2 plus 9 is 11. So then back here we have to keep our 3 outside, and then in our parentheses, now we're going to have x plus 2. We keep the same sign as that's in front. And remember, if there's no sign in front, then it's positive. Okay, and then we have x plus 9. Okay, so then that's our answer. We don't have any reducing to do because we didn't do the super diamond, we just did the normal diamond. So this one is the super diamond. And so that's this one. Ooh, okay, and this one is the regular diamond method. Okay, so there we go, and that's our factorization. I guess I'll go ahead and I'm going to box this one. I don't recall seeing squares. Actually, I guess I'm boxing the whole thing. I don't recall seeing the squareds on the answer key. So here are 2 other examples. I will look through to see if there's any other unique ones, but I think these are about the only ones. When you're factoring, you have to see if you can take out a GCF. If you can't, then you do the super diamond. If you can, then you do the normal diamond, making sure to keep the GCF out front. All right, please let me know if you have any other questions, and I will see you on the next one.